Hi everyone, I'm Sharat Chandra. Project titled as Clinical Information Retrieval System, along with my team members Nikita and Lalita. Moving on to the problem statement and project objective. The problem we are addressing is the user often struggles to find the accurate and detailed information about the services offered on the website. This creates several issues. First of all, user experience frustration when they can't get quick answers to their questions. This leads to decreased satisfaction as they expect fast and clear responses. And secondly, it results in inefficient customer support. User may resort to research out for help, which increases the workload of supporting teams and delays response times. The key issue with expecting support methods is that they lack the ability to provide context based, immediate, and responses to complex questions. Uh, and moving on to system architecture, we have user query, retrieval module, retrieval documents, question answering module, and final answer. And from here, my friend Nikita will continue.
Hi everyone, my name is Nikita and today I'll be walking you through the methodology behind our system. I will first explain how we retrieve and process the information and then how we generate the answers. Our system follows a multi step approach called the retrieval augmented generation. The first part is the retrieval system. We combine different methods to pull out the most relevant information from a medical database. First, there is BM25, a traditional keyword based search model that ranks the documents by how often the keyword appears. Next, we use a BioBERT, which is a version of BERT trained specially on biomedical literature, allowing the system to better understand the meaning behind the words. Lastly, we include MedCPT, a model made for handling clinical and medical documents. It's especially good for tasks like searching by meaning and classifying clinical notes. By combining BM25 BioBERT and the MedCPT, our system balances between keyword precision and deep semantic understanding, which is critical when working with sensitive and complex medical data. Once the relevant documents are retrieved, the next step is to generate answers using the question answering system. Here we use a GPT 3.5, a highly advanced language model that helps turn the retrieved information into the accurate answers. Instead of just copying information directly, GPT 3.5 processes the documents to understand the question's intent and generates a natural human like response. This makes the system very useful for users because it does not just give raw facts. To ensure that both the retrieval and answering stages are effective, we evaluate the system using the precision and F1 score. Now, let's quickly walk through the code execution flow to see how the system actually works. We start with the medical documents. Next, we apply the document encoding. Here, the raw text is converted into a mathematical form called the embeddings, using models like BioBERT or the MedCPT. These embeddings capture the deeper meaning of the text. Once the documents are finally encoded, we move to the storage setup phase. The embeddings are stored in the databases. Then comes the information retrieval, where we search for the most relevant documents using methods like BM25. After finding the right documents, these are fed into a RAG pipeline. This is where the system sends the documents to the GPT 3.5, which reads them, understands, and then generates a high quality answer. Finally, we reach the evaluation stage. Here, the system's performance is being measured. The live demo will be shown by my friend.
Now let us see how the clinical RAG system integrates the document retrieval from the Elasticsearch and answer generation from GPT 3.5. The system is designed to answer medical queries by first retrieving the most relevant documents and then generating human-like answers based on those documents. First, we need to import the necessary libraries like JSON, which handles the conversation between Python objects and the JSON data, which is very essential for data processing and transferring information between components. And coming to the time module, which is used for measuring the time taken for both document retrieval and answer generation, providing performance metrics. And OpenAI chart is a custom module that interacts with GPT 3.5 to generate the answers from the retrieved documents. And we have used the retrievals like BioBRT retrieval and BM25 retrieval and hybrid retrieval. These are the custom classes responsible for retrieving relevant medical documents from Elasticsearch using different retrieval techniques like BioBRT, which is a schematic based, and BM25 is a traditional keyword based, and hybrid retrieval is combining both the methods. And let's coming to the MEDREC initialization. The MEDREC is a class module that connects both the document retrieval and the answer generation systems. And we have used the constructor in it that contains the three parameters like retrieval. These parameters defines which the retrieval methods we need to use. We can choose either BioBRT, BM25 hybrid retrieval or MedSped retrieval. The question type is nothing but which specifies whether the question will be answered in the full text or as a yes or no question, which was determined by the GPT 3.5, and ndocs, which defines how many documents to retrieve, which we have set the default value as a 10. And coming to the chat class is initialized to handle interaction with the GPT 3.5 for the answer generation. And let us come to extracting PMIDs. This method extracts PMID, which is a PubMed identifier, from the retrieved documents. The PMID is a unique identifier for each medical research article. We use these PMIDs to track the sources used to generate the final answer. This allows users to verify the documents that contributed to the answer. And coming to the get answer function, this is a core function that retrieves the relevant documents and generates an answer. And first, we need to retrieve the document, which retrieves the document based on the user query using the selected retrieval. The time taken for this operation is to measure the retrieval time. And coming to the answer generation, the retrieved documents are then passed to the GPT 3.5 model using the create chart method, which generates the final response. The time taken to generate the answer is to also measure the generation time. And coming to the performance metrics, it tracks how long the retrieval and the generation steps took. The final output, it returns the final answer along with the required PMIDs, retrieval time, and the generation time. All this data is returned as a JSON string for each easy integration with other systems or applications. And and coming to the main block of the running system, this block is executed when we run the Medrack script. It creates an instance of Medrack class with a BioBRT retrieval and full text questions generations and retrieve 5 documents. Let us take the sample question. Like the LA symptoms which is passed to the system. The get answer method is also called the retrieve documents, which generates an answer. This result printed on the console of the Yeah, if we let us consider the responses from the BioBRT, and we have given the question as the identify the clinical trials investigating novel treatments for the drug resistant strains of the tuberculosis, and we have the default value we have the given as 3, so it has generated the 3 documents which contains PMID, title and the content. And coming to the PM25 retrieval as a we have given the question as an user input as identify the clinical rates investigating novel treatments for drug resistant strains of the tuberculosis, which contains the default value as 3. So it has been printed the PMID, title, content, and as well as the score. So the score is based on the completely the default values. The that contains in the given data set. Now let us try to make the mid-CPP retrieval without re-ranking. We are given the question as identify clinical rates investigation, novel treatments for drug-resistant strains of the tuberculosis, which are given the default value as 5 here. So it has displayed PMID, content and the title. So, so as coming to the results part, we have already seen before that we need to give the default value and also the user input based on the data set. So it has take the output which integrates with the GPT 3.5 and given the actual output of the system. And coming to the future work and domain expansion, we can use the extend retrieval and the cure capabilities to more specialized medical fields, which contains a, let us take the example as oncology and radiology. And for the model, let's coming to the model upgrades. It integrates latest LLMs with the GPT-4 and Medplum 2 for improving reasoning and the medical accuracy. And for the dynamic knowledge updating, we can update and develop the pipelines to continuously update the retrieval database with the new medical research. Like if we can give the user input and we just give the default value so that it can automatically get all the retrievals which have used before. It need to be get generated all at a time. Thank you. Have a good day.